So what I want to just tell you a few things about what these various lobes are, associated with in terms of function. Okay. So structurally, we've identified frontal, parietal, occipital, temporal, and then we sort of cut below, right? And we've gone more towards the middle of the brain, medial, to what we call the insula. So the frontal lobe is involved with motor movement. Okay. Whenever you are engaged in any sort of motor activity, there's going to be some sort of frontal involvement. In terms of planning motor movement, planning behavior, the frontal lobe is particularly important. In fact, there's a gyrus just in front of the central sulcus. It's called the precentral gyrus, where there's a mapping of your entire body, basically, in terms of where you're going to move. So you could stimulate here, and your face will move, and you go further, and your neck will move, and you go further, and your arm will move, and there's an actual mapping of the body along this precentral gyrus. It's called the motor strip, and it's basically if you stimulate with an electrode, right, the motor strip on the right side, something on your left side will move. Okay, so the frontal lobe is very important for movement. It's also very important for planning, for deciding on the behavior that you will engage in. So it's very responsive to, for example, social signals or social cues in an environment. And it plays a role in sort of deciding, what is the appropriate sort of social response. You can hopefully see that this is going to be a region that's going to be influenced rather dramatically, by certain drugs, particularly drugs of abuse, which tend to alter behavior, in response to opportunity to engage with those drugs, right? I should mention that the frontal lobe is also involved in inhibition of sort of emotional expression, right? It's often thought, that the frontal lobe, even though you might want to, slug somebody, the frontal lobe will help to inhibit and prevent that kind of a response, okay? It'll be interesting when we start discussing specific drugs, like, for example, alcohol, which will have an inhibitory effect on the activity of the frontal lobe. You might slug somebody, right? So the frontal lobe, motor movement, planning, inhibition of emotional sort of expression. Any kind of complex ability, like for example, let's say language, will involve more than one lobe of the brain. I mean, there'll be a network of distributed cortical regions that'll be involved when you're both comprehending and producing speech. But the frontal aspect, or the motor aspect of that behavior will involve a region in the frontal lobe. So the frontal lobe is involved with movement. Always remember that. Okay, if we cross over the central sulcus, right, we come into the parietal lobe. The parietal lobe is associated with the mapping of the body, okay? So for example, there's a gyrus just post or just after the central sulcus called the post-central gyrus, where there's a map that's analogous to the map of the body in terms of motor movement, but for sensory input. So if somebody pokes you here, there's activity that'll be detected in the post-central gyrus, in the parietal lobe, on the opposite side of the brain. If somebody takes an electrode and you have exposed brain tissue and they were to stimulate a portion of the parietal lobe, you would feel, in this post-central gyrus, you would feel something on the left side of the body. The parietal lobe is very important for forming a map of the extent of your body, where your body begins and ends, and where it is in relationship to objects and events that are out here in the the physical environment. And disorders of the parietal lobe are actually quite fascinating. So, for example, people who suffer from migraines, where there's changes in blood flow that results in inappropriate activity in the parietal lobe, sometimes will experience the sense that they're growing in size, that their body is increasing in size while everything around them is shrinking, right? Or they might get the reverse. They might feel like they're shrinking and everything else is getting bigger. So you can imagine that this may be related. Activity of drugs may somehow influence the function of the parietal lobe to produce some changes in the sensation of your body and its relationship to objects and events in the environment. So parietal lobe, I want you to think about spatially mapping your world, right? And sort of what we call somatosensation, sensations from the body, okay? As we extend back we have this region at the back of the brain called the occipital lobe. The occipital lobe is critical for visual processing. You know, primates are very visually oriented, right? We use our eyes, we rely on our vision, and information paradoxically from the eyes is actually transmitted back to the occipital lobe first before heading forward, you know, in the brain. So occipital lobe is devoted to extracting information about what you are seeing in the world. Temporal lobe. Temporal lobe is focused on another sense, right? It's focused on audition, on hearing. There's areas in the superior region of the temporal lobe that receive information from the ears, right? So information relating to sound is processed in the temporal lobe. Temporal lobe also has a very important function in terms of recognizing what things are. So if you think about, you know, you look at something, information comes in your retina, right? It's going to be sent back to the occipital lobe. This information is then going to move forward in the parietal direction to help you identify, you know, where things are in relationship to your body, right? But their information will also head in this direction into the temporal lobe to allow you to identify what things are. What are you looking at? So you can, you know, ultimately put it all together. Like this is, you know, a cup of coffee on that table, right? So the temporal lobe is important for object recognition. It is also important for memory. There are areas that are located, you know, sort of deeper in the temporal lobe, what we refer to as the medial temporal lobe, in the middle of the brain, right, on the other side here, including a structure called the hippocampus. And these areas are very important for memory function. And the last lobe, the one that often gets overlooked, is this lobe that is found sort of deep within, you know, more medial, even more medial than the hippocampus, which is called the insular lobe. And the importance of the insular lobe is that it receives a great deal of sensory information from the internal, you know, regions of your body, from the gut, from the organ systems. It also receives a great deal of information about pain and temperature, and it is mapped in this structure. So this is going to be an important player in terms of how you feel at any given time, because it's mapping, you know, the internal state of your body.